You have two identical rollers. So weight of each roller is given, which is 120 Newton. It is placed on a particular channel, right? So if the surface of contact is smooth, right, let me consider the surface is smooth, you have to identify what will be the reaction developed on the contact surface, right? So they mentioned two data. One is identical rollers. When they say identical rollers, it means that the diameter of the both the rollers are same, right? And they mentioned you some weight. Okay. Now, as we discussed earlier, so I have to draw free body diagrams for this first. Okay. So I want to draw what is the free body diagram for 2, and what is the free body diagram for 1. Right? I am mentioning 2 as the sphere and 1 as the sphere. Okay. So these are the two free body. So let me consider it according. So consider, let me, if I consider, right, if I consider 2, you have weight is acting downward. This is 120 Newton. You have 3 contacts. So you have contact here 1, 2, and 3. Okay, we will go one by one. If I consider this one, right, if I consider this one, your force is always perpendicular to the surface, which means perpendicular to this. So you will have like this. This is RB. If I consider here, your force is again perpendicular to this, right? RC. Right? What is the angle of RC? So if I consider this is my surface, which is horizontal, horizontally 40 degrees. The force is perpendicular to the surface, which means this will be vertically 40 degrees. This will be vertically 40 degrees. Yes, this is horizontal, horizontally 40 degrees. Your perpendicular force will be vertically 40 degrees, right? This with respect to x-axis, your force, since it is perpendicular, it will be with respect to y-axis. Okay, because 90 minus theta, you'll get something like this. So you'll get in y-axis, right? So and then you have a contact here, right? This contact I can able to identify when I connect 1 and 2. I connect 1 and 2, I will get a line. So this is my normal line. So, so there is that is perpendicular. So tangents will be like this. So normal is like this. So we have a force like this, R1, or I can also write as 2 1. Okay. What is the angle of R12?
40 degrees with horizontal.
Yeah, very good. So this is parallel to this, right? So the surface is parallel to this, which means if this is 40 degrees with respect to horizontal, this is also 40 degrees with respect to horizontal. Right? This is the free body diagram for sphere 2. Right? Let me go for the next sphere. So the weight is acting 120 Newton. Contact of sphere 1. How many contacts? You have 2 contacts. One is at A, other is at this point. So at A, again, you have RA, and this is 40 degree with respect to vertical. Since it is perpendicular to this surface, this is 40 degrees with respect to horizontal. So it is 40 degree with respect to vertical. Then you have one more here like this. Sorry, like this. Right? These are 2 1. This is also same. So 40 degree with respect to horizontal. Now I got a free body diagram for these cases. So as we discussed earlier, the thumb rule is to identify the forces which is having minimum unknowns. So how many unknowns are here in this one? Sphere 2. 1, 2, 3. We got 3 elements. If I consider sphere 1, you have only 2.
2 and 1, sir.
So the first thing is I have to solve this one, then only I can able to solve the other one. Okay, right. We will proceed. So I'm going to draw. So force diagram, as I told you, so first you have to put a plus sign. So something like this. Next, locate it one by one. Right, you have to locate it. So what I will do? So I have to put plus wherever it says. I put plus here, here. So this force is vertical. Like this. This is 120 Newton. If I consider RA, it is in second quadrant. So 40 degree in y axis. So I have to identify what is my RA. This is 40 degree in y axis. Right? Next, R21. So this 40 degree with x axis. In which quadrant it is? It is in the first quadrant. Right? So R21. 40 degree with respect to x-axis. So I got all the sets of angles. So 3 forces. So I can use Lami's theorem to solve this. Right? So if I apply Lami's theorem, I have to identify what is the values according, right? Degree. Right? Because this is 50 plus 40. Right? This is 90 plus 40. So it is 130 degree. What about this one? What about this place?
147.
Yeah, it is 140. Right? So we got all the force, all the angles now. So only thing is I have to apply the Lami's theorem. Right? Let me apply the Lami's theorem. So according to Lami's theorem, force by its sine of opposite angle is equal. Right? So R21 divided by opposite angle is sine 140 is equal to RA divided by opposite angle is sine 130 is equal to 120 divided by opposite angle is sine 90. Right? So now I can consider this as equation 1, equation 2, equation 3. Right? So relate it one by one. So relate 1 and 3. Relate 1 and 3. I will get. So R21 is equal to 120 by sine 90 into sine 140. So what is your R21? 77.13. Now let us relate 2 and 3. They relate 2 and 3. So RA is equal to again 120 by sine 90 into sine 130. What is our related? So okay, we identify these two values. Any doubt up to this? Yeah. Now I will go for the next one. So free body diagram for roller 2. So again, as I told you, you have to put plus here on the starting side of your force to identify its quadrant. Okay. Now 120 Newton is acting downwards. Quickly. RD towards the x-axis. RD. So R12 we already identified. So from your previous thing, we identified R12. R12 is 77.1. Right? We will do. So this comes at the third quadrant, right? So I will draw it in third quadrant. I will mention the value 77.1. 13. It is horizontally, in x-axis it is 14. So here also in x-axis it is 14. Next, RC, y-axis it is 40 degrees. It goes to second quadrant. So y-axis is right. So now I marked all the points. Right, I marked all the forces. Only thing is I have to identify what is my RC and RB. Right? Can we apply Lambda's theorem? Yeah, it is more than 3 forces, so we can't apply Lambda's theorem. So only possibility is we have to solve by resolution of forces. Okay, I think we made a tabulation and we just solved it one by one and we solved. So we know that it is an equilibrium state, which means sigma fx is 0. Sigma fy is zero. Now I'm going to identify what is my sigma fx. Right? So you find out what is sigma fx directly. I'm going to start from this work in all the phases. First RB. It is in positive x-axis, so you can directly write as RB. RC, bring it to x. When you bring it to x, it is in negative x-axis and your angle is increasing. Since your angle is increasing, you have to put sine. So minus RC sine 40. Bring this to x, your angle is decreasing. When you have decrease in angle, you put it as cos. Right? That is a shortcut. So again, minus 77.13 cos 40. Right? 120 is not applicable because it is in y-axis. So this is my fx. Right? Which means I can write as RD minus, so what is sine 40? 643 RC minus 0.643 RC minus value of this one 59.085 is equal to 0, which means I can write as RD minus 0.643 RC is equal to 59.085. Consider this as equal to 1. Now, I'll go for sigma fy and I will equate it to 0. Let us identify what is sigma fy directly. First force is already x-axis, you no need to consider. Second force, bring it to y. It is positive y and your angle is decreasing. So it is RC cos 40. Bring this to y, negative y, and angle is increasing, so minus 77.13 sine 40, and this 120 is already directly, it is negative, so minus 120. Right? So which means, so what will get? Minus 169.57 seconds. What is the value of RC? $221.35. Now you substitute this in equation 1. Then we consider this as equation 2. Substitute 2 in 1. Right? You'll get what is RB. Any doubt on this? Right, we'll proceed with the next one. Let's consider this problem. You have 3 cylinders, each of weighing 100 Newton. And the diameter of the cylinder is also given, which is 80 mm. Right? So it is placed in a channel. The width of the channel is given, which is 180 mm. And they are asking you what is the force exerted in the point of contact. Totally, you have to identify 6 reactions, right? And of course, when you look here, so when I cut this into 2,
Okay.
you can able to see that this side and this side are symmetrical, right? So in that case, if you have a problem like this, you don't need to identify the free body diagram for C, right? Because that will be equal to C. Because all the weight is same, the diameters are same. If there is a difference in any of this, diameter or weight, then it is not symmetrical, right? Then you have to identify for everything. But in other than this, so if you don't have something like that, so you concentrate on any two. So whatever reactions you are getting here, that will be equal to this. Which means, so the reaction here, if I consider this as, right? If I consider it here, right? So this reaction will be equal to this reaction, right? If I consider this as R1, this is also R1. Similarly, the reaction here will be equal to this reaction. If I consider this as R2, this is also R. And third one, the reaction here is equal to this reaction. Okay, this is R3, this is also R. Because it is purely symmetrical, so don't waste your time in identifying all these things. So you concentrate on one side. Whatever you identify the reactions on that side, that will be equal to the other. Right? You can consider it like that and we can solve it. Okay? Right. So let me consider this figure. So before we start, let us identify the angles. Right? So that is very, very important. You have your normal reaction like this. Right? Your normal reaction will be like this. This means I have to identify what is the angle with respect to this. So I need to identify a right angle triangle. Start from here and go like this. And I will also identify. So from here. Like this. This is my right angle triangle. I identify some values so that I can able to get my angle. Right? So what are the things you know? Do you know hypotenuse?
Yes, sir. Where is the angle, sir?
Yeah, hypotenuse is given. So because diameter is 80, which means this is 40, this is also 40. Totally it is 80. Right? This is identified. Now I have to identify this value, A. To identify the value of A, right? You can able to see. So if I consider another side here, right? If I consider this as B, your B will be equal to 180 minus totally 180 minus radius of this and this. So radius of your B and radius of equal to 180 minus 80, right? Equal to 100. So your B is 100. What about A?
50, sir.
So A is B by 2, half of it, right? Which means A is 50. So now I got a right angle triangle which is having 80 and 50. So you can identify your angle theta. So theta will be equal to cos inverse of 50 by 80. What is your angle theta? 1.21 degree. Right? Okay. Now we will proceed one by one. So now I'm going to draw what is the free body diagram for A. Consider for A. It's my circle. You have weight which is acting downward. Right? So weight is 100 Newton. And you have two contacts. So one is like this, R A B. Other one is like this, which is R A C. So the angle RAB and RAC, you already identified, right? So this angle is what we identified with respect to horizontal. We identified as 51.31 degree. So both are 51.31, right? So next, free body diagram for B, right? So we draw a circle. So we have weight, which is acting downward, which is 100 Newton. RBA, angle of this is again 51.31 degree, similar to this angle. Then you have R1, right, horizontal. Okay, so now you can able to see that this is having two unknowns and this is having four unknowns, sorry, three unknowns, right? So the first thing is I have to solve force diagram for B. Then I have to proceed with to indicate. So 100 Newton acting downward, 100 Newton acting downward. So RC, if I put plus, it is in first quadrant, and if I put plus here, it is in second quadrant. Okay, so RAC is in second quadrant. Horizontally, it is 51.3. Here also AP horizontally. Three forces, again, I can apply Lami's theorem to solve this, right? So what will be the angles, right? So now I can apply Lami's theorem to find it. So 100 divided by sine 77.38 is equal to RAC by sine 141.31 is equal to RAB by sine 141.1. Okay. Find out what is your RAC and RAB. Both are same, of course. Sorry. Okay. So, sorry. 141. What is your RAC is 64.05. In that case, your RAB is also same. 64.05. Now we will proceed with the next one. 100 Newton. RBA, which we know is a 64.05, right? Angle is 51.31 degree. R1 and R, right? So this is my force diagram. Okay, now I know it is in equilibrium condition, which means sigma fx is equal to 0 and sigma fy is equal to 0. Right? Let us identify what is sigma fx. So R1 positive, R2 not applicable for the axis, R3 bring it to x where angle is decreasing cos, right? So minus 64.05 cos 51.31, right? So this is equal to 0 because sigma fx is 0. So what is your R1? Yeah, 40.03. Very good. Now, sigma fy is equal to 0. R1 not applicable, it is in x-axis. R2 positive y, R2. This one bring it to y. Your angle is increasing, so it will be sign, and it is in negative y. So minus 64.05 sine 51.31 minus under this force, which is negative. So this is equal to 0. Again, in that case, what is your under? So now you can write a statement. Since if I mark this as R3 and R4, since the rollers are symmetrical, R1 is equal to R3 and R2 is equal to R4. You can write it like that. Right? That completes our problem.